Reducing fractions. Usually, when we have fractions, for example, we have a fraction that looks like this. It can be reduced to a more simpler form because a lot of teachers they want to see that you reduce them. So how you do that, sometimes I would call it like chopping it down. I used to say things like that. It's just you're breaking this down, these fractions down to a very simple looking fraction in which you cannot break down anymore. And how you do that is to find what is common among the numerator and the denominator. You know, what number you can divide the numerator by and the denominator, and which can break these down to a smaller fraction. Like for example, I can look at 12 and 18 and say, I know I can divide 12 by 3, right? I know I can do something like this. I know I can do a 12 divided by 3. And I know I can also do an 18 divided by 3. So the 12 divided by 3, I know is going to be 4. And I know the 18 divided by 3 is going to be 6. So look, I just reduce, this bigger looking fraction down to 4 over 6. And they're still equivalent. They're still the same thing. It's just now it looks a little more simpler and prettier. And I can look at the 4 and 6 and say, can I divide the 4 by a 3 and the 6 by 3? Nah, that's not going to look good. If I divide the 4 by 3, I'm going to have some decimal numbers and things like that. It's not going to be like a straight up integer on top up here. But I know I can divide by 2, right? So I can say to myself, well, this 4 can be divided by 2. Same thing with the 6. The 6 can be divided by 2. And what are we left with? 4 divided by 2 is going to be 2. And the 6 divided by 2, this is a 2, although it looks a little messed up. It's going to be a 3. So this thing reduced down to this. You can say we kind of like chopped it down. We just chopped it away and it's down to the, and they're equivalent to each other. This 12 over 18 is equivalent to 2 over 3. I will go to another example. And this is just reducing. We're reducing fractions just like piece by piece. This is what I used to do when I'm reducing fractions. I'm going little at a time. I'm dividing by, threes and twos and fives to kind of just break things down. So, I would have, let's say, an 18 over, let's say, 30. And I'll look at them and I say, can I divide them both by 2 and this and that, or 3? And you can, right? You can. I can look at this and say, okay, the 18 I can divide by 3, let's say, for example. So I would say I would do something like this. I would say, okay, 18 divided by 3, and then so it's going to be 30 divided by 3 also. And that's going to take us to 18 divided by 3. That's going to bring us to 6. And the 30 divided by 3, that's going to take us to 10. Then I look at the numbers and I said, I think I can break them down. Can I divide them by 3? No, I can divide the 6 by 3 again, but then the 10 have to be divided by 3, and that's not going to look pretty. But I know I can divide them both by 2. So I can say, okay, 6 divided by 2, and I can do a 10 divided by 2. And so now what I have, 6 divided by 2 is a 3, and a 10 divided by 2 is a 5. So this 18 over 30 has been reduced down to 3/5, 3 over 5. I kind of approach this a little backwards compared to how I would do it. Usually I would start dividing by 2, and then I will divide by other numbers. And I'm going to use that method right now. So let's say I have an 18 over 42. And I'm wondering, can I divide them by 4? Can I divide by 6? This and that. Usually I would do 2. I would start with 2 because 2 is, it's a simpler number to break this thing down, right? So I would do something like this. I would go 18. Okay, I'm gonna do 18 divided by 2 because I'm just gonna break this down piece by piece. And then there's a 4. Oh, I knew I messed up with the colors. Okay, so there's a 42 divided by 2, right? So this is how I would approach this. 18 divided by 2, and I'm gonna have a 9, and then a 42 divided by 2, I know I'm gonna have a 21. Then I'll look at them and say, well, I know I can't divide by 2 anymore. I can't chop these in half. But there's some relationship with 3 going on here, right? There's some relationship with 3. So I know I can divide the 9 by 3 and the 21 by 3. So that would be my next approach. So I would do something like this. I would say, okay, a 9 divided by 3 and a 21 divided by 3. Right? These arrows just showing the progression. And then so this is going to lead over to 9 divided by 3 is going to be 3. And a 21 divided by 3 is going to be a 7. And then I look at these and I say, hey, I can't do anything more. I can't divide, I can't divide this 3 by something and then this 7 by something and get a nice rational number. You can't. This is it. This is the simplest form right here. And so I just simplified these fractions just by doing piece by piece. I would do this method sometimes, especially starting out. It's good to do it like this because you're just working the fractions down into their simplest form. And that's just a little shortcut, a little suggestion. There's a more formal way to do this, and we will go over that. I should do it now. Now, this method, we reduce the fraction from this down to that by doing multiple steps. And this is how I used to do it, as I was learning math. But there's a little faster way to reduce some fractions because, our teachers always want us to reduce the fractions from this bigger fraction down to this reducing or simplifying. That's another word in which they will say. So let me show you the other way. So this other way is finding the greatest common factor between these two numbers, the numerator and the denominator. So let's look at the factors of 12 and 18. And we're going to look for the greatest that is common among them. So the factors of 12, what numbers make 12 when you multiply them together? So, 1 times 12 would be 12. A 2 times 6 is 12. 3 times 4 is 12. What about 18? 1 times 18 is 18. 2 times 9 is 18. 3 times 6 is 18. And so what is the largest that is common among them? Now we have some numbers that are common, like 1. We have a 1 here and 1 is here, that's common. And 2 here, 2, that's a common. 3 and 3 is also common. But the largest common is 6 and 6. That is the greatest common factor. So we're going to divide both the numerator and the denominator by the greatest common factor. In this case, it's 6. So 12 divided by 6, that is going to give us this 2. And the 18 divided by 6 give us this 3. So you can see it's less steps, and the better you get, or the more practice you do, is the more you can do this in your head, and you can see that it's 6. But this is what you do. Down here we have a 18 and a 30. We still have the 18 here, so I'm going to recopy this 18. So the factors of 18, the factors of 18 are 1 and 18, 2 and 9, 3 and 6. The factors of 30 are 1 and 30. 1 times 30 is 30. 2 times 15 is also 30. 3 times 10 is also 30. And a 5 times 6. And just by looking at that, at this, we can see the largest that is common among them is again 6. That's the largest number that is common. So this is the greatest common factor. So we divide both the numerator and the denominator by the greatest common factor. So it's 18 divided by 6. That gives us that 3 that we had originally. And the 30 divided by 6 gives us the 5. You see how it's just less steps compared to what we had before, with a whole bunch of breaking down the numbers by just keep dividing by 2 and divide by 3 and so forth. And so that's how you do that. You just find the greatest common factor, and then you divide the numerator and the denominator by that greatest common factor, and you will have a simplified fraction. And this is important to know, because this will, first of all, teachers, they want to see answers like this in simplified form. And so we have to get used to this. Okay, and that's all for now.